But what is true about the validity of our projections every period of time we go beyond right now into the future? So every period of time further out that we project, what is true about those projections?
Accuracy.
They're weaker.
Yeah, they're weaker. Yeah, I like the visual image of standing on a lake where the ice is frozen over. And those first few feet in from the shore, fine. You know, the ice is probably 5 or 6 inches thick if it's in the dead of winter, and no problem at all, especially if we're not very deep there. But as I go a few feet further out, the ice is getting a little thinner. So 1 step out, I might be fine. 2 steps out, I might be okay. 3 steps out, I might start to feel the ice kind of giving a little bit away, and I'm not going to go the 4th step because I don't want to be a frozen cube in a few minutes, right? Every step out that we take, every time period out that we project, that credibility, the accuracy of our projections becomes more questionable. And so when we have that, we have to start to water them down a little bit. At the end of our period of time where we think we can credibly forecast, we have to make a wholesale shift. Maybe we have forecast 12% in year 1, 11% in year 2. Maybe we went all the way down to a forecast of 3% in year 3 because we think there was a likelihood of a recession in that year, maybe an expansion the year before, so we're back up to 9%. But after our crystal ball starts to become fairly hazy, not very sharp, we've got to go from whatever the number is all the way down to some nominal growth of maybe 2, 2.5%, 3%. And we're going to think about employing that growth rate for the rest of time. How long does the rest of time go when we're talking about a corporate asset?
Sold or dissolved? So it's no longer there?
Yeah, till it's no longer there. So Jason, the company you and I are dealing with is a printing company. And we have these huge web presses, right? We bought these presses. They cost us about $1.5 million each. We've used them for about the last 6 years. You know, they're not the newest technology, but we're still pretty hot. And we've maintained them very, very well. We think they've got probably a physical life in them if we continue to maintain them for probably another 10 or 15 years. So would we quit seeing a growth in revenue from those assets at 10 or 15 years? Would they be completely without any productive value then, or do they still have some productive value?
Most likely still have some productive value.
Yeah. So maybe I go ahead and sell them off to Scott at some nominal amount. Let's face it, by then they're 20 years old, they're depreciated badly, but Scott doesn't have such high intensity needs for them to not serve his purposes. They've got some value, but they don't have intense value, right? Or instead, I went ahead and sold them off to Heather. Heather is a junk dealer, and we sold them to Heather, and she's actually just taken them down and have them crushed and then smelted or melted down, and they're going to appear as iron ore that we make some bridge beam out of, or some roof panel, or maybe they go into that new car that Nate's going to buy. The point is, they may change in structure, but unless they literally disappear into a black hole, they still exist as matter and will reappear as some element that has some productive value, or maybe very small productive value, but some productive value. In fact, along those lines, we can then argue that a company's assets will have productive value in perpetuity, maybe very small with a very small growth rate, but they will have productive value in perpetuity. The company may have disappeared, but its hard assets still exist. The items we used to manufacture may no longer be interesting to people, but now we can maybe repurpose our production facilities for something else. Does that make sense? Are you able to get your heads around that concept of those assets exist in perpetuity as much as we understand what that term means? It's the reason the Gordon growth model, and I think I've introduced that to you, but we'll talk about it more over the next couple of weeks. It's the reason the Gordon growth model is a viable mathematical model, okay? That cash flow may slow down, may dramatically reduce even, but there's still some productivity we get out of any tangible asset as long as the matter still exists and we reconstruct it into something useful within our productive society. Okay, anything else you want me to discuss with respect to revenue forecasts? I'm thinking mostly about those of you that are working on your capstones or are about to have to do some of this. Okay, let's move to forecasting performance otherwise now. And now I'm going to go and start to think about how we apply a revenue forecast, but I got to think about this explicit and continuation period as well. So let's first look at what factors impact future revenue. I guess I just kind of talked about some of this and talked about how they may be critical, they may not be, they may be robust, they may not be. I've just talked through them. One of the things that we might have to think about is we can credibly forecast revenue changes out for the next 2, 3, 5 years, but could I credibly forecast what my revenue is going to look like in 20 years? Not really. I mean, I might generalize it and say it should be higher than it is today. I might even generalize it and say it should be higher than it is 5 years from today. But do I know how much higher? I don't. And because of that, we're going to do two things here. We're going to think about and label that next 3, 4, 5, maybe 7 years as an explicit period. So it's a period in time when we explicitly, expressly, discreetly forecast our company's revenues and expenses, so we forecast our cash flows. Beyond that point, beyond our explicit period, we have what we'll think about as a continuation period. Now, some of you have been schooled to think of this as a terminal value period. So you've thought about this as a discrete and terminal. I more often than not use the terms explicit and continuation. And I'll show them to you graphically in just a moment. Well, okay, fine. Let's assume that King and I have been looking at the company and we've decided that we can credibly forecast our revenues out for the next 3 years. And to forecast them out beyond that, we're really getting ahead of ourselves and it's an act of hubris. But we've identified that over the next 3 years, we should have revenue increases of 12% next year, maybe 11% the year after, maybe it slows down to 7% the year after. So maybe that averages out to what, 9.5%. And I'm guessing at the number. I'm not doing it with my calculator. So we can either apply the year-over-year changes in a very specific way, or we might generalize this a little bit and say that they average 9.5% for the next 3 years. But beyond that, after year 3 and all the way through perpetuity, so forever, we're hard put to give a number to it, aren't we? But is there a number that we should be able to count on? I think there is. And that number would be the expected long-term growth of our economy. Isn't it realistic, Kang, that we should be able to grow our company at least at the same rate that the economy is growing?
Yes.
I would hope so. Otherwise, I'm not sure why you're paying me, right? Okay. So we're going to go from whatever our explicit forecast period projections are to our continuation projections that will cover perpetuity. And that number probably will be 2%, 2.5%, 3%. It's going to be commensurate with the long run growth of our economy. Okay. However, in the explicit period, we're going to have to think about whether or not some of these growth rates are persistent, so long-lived, or whether they're not persistent, or for what periods of time they're persistent. So let's make an assumption that we were able to put some innovation into our company that gave us an extra 2% growth this next year. And that was going to be by us adding new products and services to our existing customer base. Not so much growing the customer base, that's a little bit separate, but just new products and services to our existing customer base. Would it be reasonable that within the next 2 years, that whatever customers we have that are interested in that new product line will probably have begun to adopt it? I think within 2 years, it's probably realistic, right? In which case, that 2% growth is only going to be effective for us for the next 2 years, and then we'll begin to peter out. It's not persistent. Whereas, if we introduce a brand new product to the marketplace at large, and we have to expand still into that marketplace. We don't have the whole thing yet. The growth that might be represented from that might be perpetual. It might be persistent for us. So you got to think through this concept of what elements of your company's growth are persistent, and if they are, great. If they're not, for how long might they stick around as you're thinking about our revenue forecast. Let's now look at this graphic element with this continuation period and the explicit period, which I see I have spelled wrong. I love that when I do that in front of other people. So let's assume for a moment that I'm just looking at a timeline here. And time 0 is today, right? Time 1 is a year from now. Time 2 is 2 years from now, and so on. If I believe that I can expressly or explicitly forecast my firm's revenues for a period of 5 years, that's probably realistic, maybe a touch generous, but I'll say that my explicit period is a 5-year period. But it's not the end of the growth of my revenue. Somehow my company will continue on, either as the company that exists today or in somebody else's hands because we've been acquired, or we closed down and we parsed our assets out, or we had to take them to the junkyard. It still all exists in some way. And that next period of time, that continuation period, goes on forever. And it starts at when the explicit period ends. So if I have an explicit period or an expressly forecast period of my company's revenues, a very rigorous period of 5 years, then the next year, which I would think of as year 6, would be the first year of my continuation, which means that the end of my explicit period is also year 0 of my continuation period. Let me walk back through that again. So if I've got my company, I'm thinking about my base year as year 0, it's now, and I believe that I can go ahead and forecast out, let's say 3 years of good, credible revenue growth. And beyond that, I'm going to apply some very nominal 2, 2.5%, 3%. I'm going to say I've got a 3-year explicit period and then a continuation period that picks up where the explicit period leaves off. In which case, if it's 3 years of explicit, the 4th year would also be the first year of my continuation. You're going to have to look at this one a couple of times to nod your head and really mean it, by the way. Okay? So we'll talk about it tonight. We'll talk about it again, and you're going to practice it in the interim, and it'll become commonplace for you. But just think about these as being 2 completely different periods of time, and the continuation period starts when the explicit period stops. So if I could come up with a value of the asset out here for this continuation period, if I have an equation that lets me do that, that value would live at this point in time out here in the future, wouldn't it? And if I want to create a present value from that, I've got to bring that value back to today. Well, all valuation models that we're going to talk about, or that I can really even think of, have a common structure to them. The value or present value today of that asset when gauged by that model will be the present value of its discounted cash flows during its explicit period, plus the present value of the continuing value. So the value today of an asset is the present value of the discounted cash flows in an explicit period, plus the present value of its continuing value. And the continuing value will be some summation of all possible future cash flows. Let's look briefly at a structure that you've now seen as you've been working on the problem set, or I think the Excel assignment for this week. So here we have, for the company, we have a base year of 2019, and we've identified that we have an explicit period of 5 years, so 2020 through 2024. And we have forecast our free cash flows for those years using a express or explicit, very rigorous year-over-year structure of some kind. And then we know that there's going to be cash flow beyond that, but the only one of those we're willing to even think about is cash flow for year 6, which happens to be year 1 of our continuation period. So in this case, which year of time would be year 0 for our continuation? Year 5. Exactly. So the last year of the explicit period is always year 0 for our continuation or for our terminal period. The last year of the explicit period is always year 0 of our continuation or terminal period, because the next year after the explicit period is year 1 of this newly thought of time structure. Remember that when we look at the Gordon growth model, or this dividend yield model that you've been exposed to before, P0 is equal to D1 divided by R minus G, or maybe we've generalized that by saying value at time 0 is equal to some cash flow at time 1 divided by a discount rate minus a growth rate. That would be an example of a continuing value, and it's using the Gordon growth model. It's giving us a value as of time 0 using the next period's cash flow divided by discount rate minus the growth rate. Now, you probably recognize that that's the same thing as the sum of all the future cash flows discounted for rate and time, assuming those future cash flows grow at a constant rate. Think back to the discussion we had about the present value structures and the videos I've given you on present value structures. And think back to the Gordon growth model construction that you saw there. Well, that's simply one of the structures of a continuation term or continuing value. And if I can take the present value of my discounted cash flows, present value of my discounted cash flows, which I've got those discounted cash flows right here, because here I've got the cash flows for the explicit period. Here I have the discounted values of them. And here I have the sum of those. It's simply a summation term. That 7.53 is the sum of the present values of those discounted cash flows. So that's my PV DCF, or PV free cash flow in this case. And it's right here in my multi-columnar structure. Well, now I've calculated the continuing value. I use the cash flow at time 1, and in this case, time 1 was 2.92. And if I divided it by a discount rate, or WACC in this case, minus growth, and it gave me 21.38. But this number of 21.38 lives all the way out here in 2024, because it was the value at time 0, continuation term time, was equal to the cash flow at time 1, which is the next year, divided by the discount rate minus growth. So it lives all the way out here in 2021, or 24, excuse me. And if I want to add it to the present value of the discounted cash flows, I've got to create a present value of it as well. So I've got the present value of my continuing value, and I got that simply by taking this continuing value and dividing it by 1 plus whatever our discount rate is, in this case to the 5th power. And together those give me my value, or my present value. Does that make sense construction-wise, structurally? Is it starting to become a tiny bit clearer than it was the first time we discussed it?
So
Yes.
sorry, go ahead. Sorry, Scott.
Oh, no, go ahead, Jason.
I'm just trying to wrap my head around 2 values at the same period of time. So there's a current value of 0 associated with, in this case, year 5, and then also a present value of explicit period 5. How come they're not? Well,
no, you're onto something. So my explicit period, years 1 through 5, has a series of cash flows associated with it, right? And I can discount each of those cash flows by the discount rate to the power of whatever time is. And I can then add them all up. And this would be the present value of all of the discounted cash flows during my explicit period. And we're going to call that 7.53. Fair enough? Now I'm going to use the cash flow starting in 2025. That happens to be cash flow at time one in continuation time, right?
Okay. Yep.
Okay. And if I take that cash flow, which in this case is 2.92, and divide it by the discount rate minus the growth rate, it gives me a value as of year 5. So I've got the value of the cash flows plus some terminal value or some continuation term built on the next year. Let's work to move to the spreadsheet for just a moment, and you'll see this again. And in this case, I'm using Mira Dravana, of course, and you'll recognize these numbers, exactly what we're working off of. So here I have the summation, and it expresses itself again right here. But here I've got this 20.2, which is the 292 coming out of the first year of my continuation. So that's the cash flow in time 1, and time 1 comes after continuation time 0. So if time 1 is here in year 6, time 0 for continuation must be in year 5. Okay? So I'm taking that divided by a discount rate minus a growth rate, and it gives me some value. Well, that value of 20.2, what does that mean to me? Well, it's the value of all the potential future cash flows that we're ever going to see beyond this moment in time. And we've wrapped them all up into one using this Gordon growth equational structure. Okay? Well, but that number is current or present as of time 0. Well, when is time 0? It's the last year of the continuation. So I know I've got some present value of some cash flows that run through that time period, but I've also got the present value of an asset that's going to run through that period, which is why when we did this in a net present value form, and for our when I was introducing you to this multi-columnar structure, I add those two numbers together to get my net present values. So I've got a present value here and present value here, but they're for that year. I'm going to have to discount them both back to today. Does that help at all, Jason, or am I just repeating myself?
Nope, that helped. That helped. I conceptualized cash or constant continuous value at 0.
Yeah, the continuing value. You're going to find, by the way, that repetition in this concept is what helps, because it is somewhat counterintuitive. So I've already droned on through this now twice. I'll do it probably one more time before I expect you guys to have really conquered it for yourselves. Okay?
Quick question. When I did this, I rebuilt the whole thing. Some of the values are off by like 0.1. That's not a big deal, right?
Yeah, it's not a big deal. Is that Emilio?
Yeah.
Emilio, you probably have a value in here somewhere that you're using a original input number rather than a calculated value, but it's so insignificant that it's almost meaningless. If you would like at some point for me to look at the spreadsheet that you did this on to find out where that difference is, I'm happy to try and triage it for you.
I mean, I'm not really worried about it. Like, I built it dynamically with all the numbers. What I'm doing is like I'm doing it exactly the way yours is there. I have like the original data source, and then like every subsequent tab is like its own week exercise, and I'm referencing all the data back to the original. So everything is dynamic, but I'm wondering, I probably just did a round somewhere that's like different.
Probably, yeah. It's a somewhat insignificant value change.
Yeah, yeah. I mean, yeah. When I did the MPV and all that, I mean, the numbers specifically that come to mind is, for all the MPVs, instead of 3.38, I have 3.39. But all of them are dynamic formulas, and all of them are doing it the way that you're showing here. It's just
Got it.
I might have done a round function somewhere, and
yeah, perhaps.
what happened.
Okay. What other questions would you guys have here before I continue on?
What was the calculation for the value?
For which value? Down here?
Yes.
It's going to be the present value of the discounted cash flow plus the present value of the continuing value. In fact, that structure is going to be common amongst all valuation models. So you see I've given you the present value of the discounted cash flow, continuing value, present value of the continuing value, and when you add the present value of the discounted cash flow to the present value of the continuing value, you get a present value, not a net present value. The net present value would require that we have some cost or investment function that we're netting out against this present value. Okay.